showing you how to do a material balance. Today, our material balance includes a room with a filtration system, meaning we have two inputs and two outputs from the room. And we have two people in the room who are admitting an illness because both of us are sick right now. Before doing any material balance, we need to draw a picture. This is room 1610, our lecture hall, where Ella and Charlotte are studying, but they're both sick. Notice that the room volume is 1,000 meters cubed. Our emission rates per person is 5,500 particles per minute. The flow in and out of the room is 0.6 meters cubed per minute. The filter flow is 2 meters cubed per minute, and the filter efficiency is 99%.
And now we label our picture. We use Q's to label our flow and N's to label our concentration. Our concentration going into the room is 0 because there are no particles going in. Our concentration out and concentration within the room is the same. And our filter concentration coming out is 0.01% of the concentration going in because the filter is 99% efficient.
All the other flows and concentrations are given in this information. This is our material balance in written form. It's always accumulation is equal to inputs minus outputs. Since in this case we're trying to find the steady state, we have 0 is equal to inputs minus outputs. The units for each input and output term in the material balance has to be mass over time. Our emission rate is already in those units, so we don't have to multiply it by anything, but for our flow terms, we have to multiply it by our concentration terms, or our N terms, because flow rate is in volume per time, and our concentration is always in mass per volume. So when you multiply those together, you get mass per time for the units for each term, which makes sure that when you solve the material balance, all your units cancel out. Okay, we're going to start with our inputs. Our first input comes from this flow and this concentration in. Yep. Okay, and then our other input into the room, it's a little tricky with the filter, but it's actually going to be this flow right here because that's what's going into the room. So that's QF and then our 0.01 times N. And then our other input is the emissions. So we're going to do 2 times the emission rate because our emission rate is per person and we have 2 people. Okay, now we subtract our outputs. So we have Q times N, which is this flow out of the room. And then we have to do this flow out of the room and into the filter, which would be QF times N.
After adding in all of our known values, we're left with this equation, leaving the only unknown variable to be N, which is our steady state concentration within the room. After simplifying our equation and gathering all of the N's together and the regular numbers together, we get that N equals 4,263.8 particles.